So let's talk about the box. When we sat down and thought about how we were going to make Xbox One, we realized that obviously the goal of this was to have a gaming console, right? We needed something that can get into the living room that people wanted to play their games on. That meant we needed next-gen performance. Obviously, shipping a console that was just a little bit better than Xbox 360 isn't as compelling as shipping something that's way better than Xbox 360. In order to do that, we used a lot of modern architecture. We have a single system on a chip that's provided by our partners at AMD. It has 8 CPU cores on it. It has a very powerful GPU on it, both in terms of compute power, but also in terms of compute versus watts, because we want it to be as low power as possible. We don't want very loud fans blowing all the time, like on previous generations, for example. We felt it would be really cool to have a Kinect built in, both from the perspective of game developers being able to do something beyond just the controller. And having that Kinect be there for every single console means they can count on it being there. They don't have to make a purple box Kinect title versus a green box not Kinect title. They can all be Kinect enabled in some way. And whether that's speech or whether that's advanced gestures, it was there for them to be able to do that. It was also important because this one was about entertainment. The game development and gaming aspects of it are very important. But what was really cool about it was having the Kinect in there so that we could do more controls for controlling the entertainment in your living room as well. Right? It's neat to be able to plug in your TV and be able to use the Kinect to do voice commands to watch different TV channels if you want to. This had to be seamless and instant, which drove a lot of our operating system considerations, which we'll talk about. But basically, the idea here was we wanted to be able to switch from app to app or game to game as quickly as is humanly possible. It's cloud-powered. It's plugged into the internet all the time, or can be plugged into the internet all the time. And when it is, we actually write your save games up into the cloud. We can actually use the cloud for compute with this as well. And we'll talk a little bit about the cloud compute aspect of it and the save game part of it here as we go on. And like I mentioned, it works with what you own. There's an HDMI in port on the back. And the HDMI in port lets you take whatever HDMI signal is interesting to you and run it into the Xbox One and have the Xbox One layer in all the other advanced things that it can do as well. So you can be watching TV with an NFL app snapped into the side so that you can kill 2 birds with 1 stone and watch the thing that perhaps your significant other wants to watch instead of the NFL that day, or perhaps there isn't a game that you're actually interested in, but you can actually see all the games and what's going on the side. This, of course, is the box that goes in your living room, but that wouldn't be complete without the cloud. And the other part of the cloud that goes with the Xbox One is Xbox Live. Today, Xbox Live is the premier multiplayer gaming service. We have millions and millions of players playing on it all the time. It exists to do dedicated servers for these guys so that they can matchmake. We can help match people up. Their leaderboards are stored here. Their achievements are stored here, all attached to their live profiles. This is extremely important because this ecosystem is part of what makes Xbox unique. The fact that these people can find each other, become friends with each other, have rich presence, rich identity, rich communities, all enabled through the Xbox ecosystem is very, very important to us. There's a lot more cloud processing and AI on the back ends of Live than there ever has been. We do this both to manage server loads and keep the servers up and running as best we can, but also to help with matchmaking. It's very, very important that you find somebody interesting to play with as opposed to somebody who's not interesting to play with. Not interesting can have a lot of different definitions. One not interesting person to play with is somebody who's twice as good at the game as you are. This turns out to be no fun for you, perhaps a lot of fun for them, but only for a certain amount of time, and then probably they get bored too, right? So matching up people that have the same interests, the same skill sets, is very, very important. And being able to do that in a way where you're not necessarily counting on your friends to be online, but you can play with anybody is really, really important to us. The Kinect is in every one of these boxes. This Kinect is significantly more powerful than the previous generation of it. We have a 1080p camera inside of it that runs at 30 hertz. That's got a full color video stream. There are depth sensors on it that have significantly more fidelity than they've ever had. For example, the field of view, both horizontally and vertically, is twice as wide as it was. It can sense things up to a foot closer and 3 feet farther out than it could originally. The definition is so good that we can actually look at the depth profile of your face plus the color feed and recognize you and log you into Xbox Live when you look at the Kinect. All you have to do is walk in the room, and it logs you in. My kids love this. They walk into the room, and the Xbox says, "Hi." And they're like, "Oh, Xbox is happy to see me." So, you know, at least somebody is. I love my kids, really. They're probably watching this right now and taking notes. But the thing that's cool about the depth recognition is the fidelity, right? Besides the skeletal tracking that we can do, which is significantly better than it was on Xbox 360, there's no noise in the skeleton today. It's very stable. If your feet are cut off, the ends of your feet don't do this like they used to. They actually just track where they should be. You can be tracked sitting down now, which it couldn't do very well before. It can recognize that you're smiling. It can recognize that your eyes are open or closed. It knows that I'm wearing glasses. It can tell my heart rate. It can tell that I'm engaged, either looking at the console or looking away. Okay? All of these things are available to game developers today to make a much more rich experience, as well as having all of the speech capability that was there from the first ones as well. We built Skype into this, so you can use the high-def camera on this to Skype with people from your couch or from your living room. Again, the microphone's acting as the way to pick you up. The microphones also act as a way to chat, so you don't need a chat headset. We can actually feed the chat through the audio that's in your speakers, and you can actually pick up what you're saying by the Kinect microphones. Again, making it much, much easier and more seamless to do multiplayer. One of the most important tenets when we started thinking about this, though, was that we wanted this to be an extension of other Microsoft platforms. We didn't want the Xbox to be off in its own world necessarily anymore. We wanted to think about how are we going to work with all of the other things that Microsoft has done, with the new WinRT API set, with the old desktop API set, right? How do we take apps from the Windows and Surface and phone world and move those onto Xbox One? How do we take games from the same universe and move those onto Xbox One? And that drove a tremendous amount of the architectural decisions that we made. But it is true and it's real, and the WinRT APIs are just there. And they're there on both sides, which we'll talk about what that means in a second. But the fact is that even a game developer doing the most tight, to-the-metal game code that he possibly can is still using WinRT APIs to do things like talk to Kinect. He's still using WinRT APIs to talk to things like the controller or find out what live users are there. And that exact same code will move across all Microsoft platforms in the threshold timeframe. So how did we think about building this box? When we looked at where we were relative from 2005 with Xbox 360 to Xbox One, we thought about all of these different things that had changed in the world. Probably the biggest thing that had changed in the world between those two timeframes was the fact that we now had these new markets and new devices of people playing games. Okay? Think about it from a marketing perspective. There were no Facebook games in 2005. Okay? They became ubiquitous around 2008, 2009. Everybody was doing it. And that created an entirely new generation of game players that had never even considered doing some of this stuff before. And those game players then went and bought smart devices. And those smart devices began to have games in them, right? We live in a world today where we carry an extremely powerful computer around with us all the time. And that extremely powerful computer does a lot of really interesting things. It used to just answer the phone. It doesn't do much phone work anymore, at least mine doesn't. Sometimes I get a phone call from the doctor saying, hey, you know, your appointment's tomorrow. And I'm like, yeah, thanks, click. Right? But I don't talk to my wife on the phone. I text her. I text my kids for the most part. People that need to find me at Microsoft do it through link or through text. Right? We just don't live in that sort of voice phone world anymore the way that we used to. What that means is that you carry this with you all the time. And that means that whenever you're bored, whenever you've got 5 minutes between two meetings, whenever you've got 10 minutes before your plane's going to take off, you pull it out and you do stuff. You check the weather. You find out what stocks are doing. You play a game. Okay? It is now with you 24/7, this ability to play games and to enjoy yourself and to be entertained by this little tiny device that you're carrying with you, or in my case, the big giant 1520 Nokia. But we live in a world now where these devices are ubiquitous, and how does that make people think differently about a gaming console was something we had to think about as we were designing this. The other thing is that this generation of people, the digital natives, if you will, the people who live on the internet, right, the people who exist in this world of constantly being connected, multitask in ways that is unfathomable, at least to a lot of people of my generation. I watch my daughter, who's 10 years old. She sits in her room. She has a Harry Potter audiobook playing on her little stereo thing. She is on the phone texting with her friends, and next to her is her Game Boy 3DS where she's playing Pokemon. Okay? And it isn't that she's oblivious to any one of these things. She can tell you exactly what's going on in Harry Potter. She can tell you exactly what she was texting, and she knows exactly what's going on in Pokemon. But this is how she operates. Okay, done texting that, put that down, play some Pokemon, play, oh, new text came in, let's see what's going on here. Okay, Harry Potter did that, that's really cool. Well, keep playing. This is how they think today, right? These smart devices also allow you to switch between one thing and another very, very quickly, which is what enables this kind of multitasking, right? I can switch from thing A to thing B in seconds as opposed to minutes. And that became very, very important in how we thought about the design of Xbox One and the operating system architectures and how we were going to put it all together. Obviously, there were new technologies that we wanted to bring to bear as well. The Kinect being probably the most obvious example of this, where we dramatically improved its ability to see and understand what it was that you were saying or doing in your living room. But we also wanted to take advantage of the fact that GPUs had gotten faster and CPUs had gotten more multi-core than they ever had. And memory was faster than it ever was. And there were enormous amounts of it now. Right? The Xbox 360 came with 512 megabytes of RAM. Right? Game developers get 5 gigabytes of RAM in Xbox One. The whole box itself contains 8. So there's a tremendous amount of new technology that went into place and expansion of existing technology. And how are we going to make all that work? Right? Now, we thought about all this, but then we also had to think about games. Because the fact of the matter is, this is a gaming console. It is important that it know how to play games. We live in a world today where game art is significantly larger than code. And this is true regardless of how casual or how AAA or how Call of Duty or Halo your game is. It's an order of magnitude larger in most cases. Just by pure disk space alone, it's actually 2 or 3 orders of magnitude larger. But the amount of data and art content and things like that that go into these games is just ridiculous today. If you look at the number of cars that's in Forza Motorsport 5, you look at the number of decals that are available to customize those cars. You look at the number of colors that are available, the number of different kinds of materials that are available, right? Artists spent years, literally years, building all of the content that is in that game. And it has to look good, too. It can't just be built and thrown over the wall, which means you have to iterate on it, right? They didn't just build the McLaren once. They probably built it 2 or 3 times in order to get exactly the one that they wanted to. Plus, there's the fact that games also have different levels of detail for these pieces of art, right? The furthest away, very small polygon counts, close up, gigantic polygon counts. An artist has to build that entire set of cars for all of those distances, in some cases 4 or 5 different copies of the car. Not to mention the characters, not to mention the cities, not to mention the roads, not to mention the trees, not to mention the skies, not to mention the mountains, not to mention everything else that went into it that convinced you that you were in this real world. So art is a lot bigger than code. That means that we need a lot of stuff and space for the art. We need big hard drives. We need large delivery mechanisms from an optical disk perspective. A lot of bandwidth would be really helpful if you want to download it, right? A lot of memory would be helpful if you want to actually play and have all the cars be loaded instead of having to swap memory all the time, which turns out not to run very fast. So that was what drove a lot of the size decisions around how we make things, was we wanted this next-gen feel. Games also, however, on consoles have to be predictable. Nothing is worse when you are playing a console game than having the game hitch. When it hitches, you want to throw the controller through the TV. When it hitches and you missed a shot at somebody, you want to throw the controller at the TV as hard as you possibly can. So we want to avoid that if we can. The only way to avoid that is by making it predictable, right? You get 6 CPU cores inside the console, 4 on one side of the bus and 2 on the other side of the bus. Okay? Those 6 CPU cores have to respond the same way every time. If they don't, and your game runs differently every time you run it, that's bad. Right? Which means that there's a lot of things Windows can't be doing in the background all the time. Because if it does, it will screw up that predictability. We can't have that. And that led to operating system decisions and how we were going to do things and what made sense and what didn't. Right? But that predictability is critically important. When these guys say they want to run at 30 frames per second at 1080p, or they want to run at 60 frames per second at 1080p, they're not kidding. They really mean 60 the whole time. And 16.67 milliseconds is not a lot of time to get stuff done. It was also very important that we protect our IP.